Hello, welcome everyone. My name is Daniel Moyer. I'm joined today with Nathan Heston, and we're going to be doing a webinar on off-grid living, specifically with our stacking 6.6 battery, our generators, and talk a little bit about sizing, how to approach the systems, and some of the challenges of living off-grid. Welcome, Nathan.
Thank you, Daniel, and welcome to all of you that are joining us.
This is a NAPCEP accredited course, so we will be issuing a 1 hour of continuing education credit. The chat has been disabled, but the Q&A is still open and available, so put any questions or comments you have in there as well. And then at the end, our email is going to pop up, and we'll ask that you email us so that we can send you those NAPCEP credits. Well, let's go ahead and get started. One thing I wanted to start off today with is, as many of you might know, the 30% tax credit available to solar plus storage, or even just storage, is under threat right now. And SIA, which is Briggs Stratton is a member of, the Solar Energy Industries Association, has starting a way to lobby or get your voice heard, and they started Solar Powers America. So here's a form here that you could fill out. The link here will take you to that form. Many of you are probably already aware of these changes and are taking action, but I ask that you take a look at this and please reach out and make your voice heard on this topic. Additionally, before we get started, I want to invite anybody out here who hasn't installed our 6.6 battery yet, that we will give you $1,000 off your first install. And then once you've done your first install, we will welcome you into one of our installer program. That will make you eligible for $100 off every battery you do in the future. So if you install a 6.6 with a 3 stack, we'll give you $1,300. That'd be 3 batteries. If you do a 2 full stack, which would be 3 and 3, it'd be $1,600. The sales phone number is down there. Please reach out to us. Please reach out to Nathan or I if you have any questions, and we're happy to get you onboarded with this. So really quickly, just to make us set the stage here, in a lot of ways, off-grid solar was how this entire industry got its start. You know, the first net metering agreements, the idea that you could backfeed the electrical grid, really didn't come out until the 90s or even the early 2000s. So it was these remote homes and cabins were the first people to be able to leverage photovoltaics and batteries. At that time, it was all lead acid batteries. And most of these off-grid systems also had to leverage generators, because the systems, if we were to oversize them for the winter, that they would be much too expensive. And considering, if you look at those solar panels on the right hand side there, those are very expensive. When I first started in 2007, you know, we were using evergreen 175s at $4 a watt. And Nathan, you know, I went back into some of my old home power magazines and found some of these articles here where, you know, you're looking at here, some of these Siemens 100-watt panels are $477. So again, these were the pioneers. These were the people that started that. And there is a great group of people, solar pioneers, that there's a documentary coming out that will be free to view. Keep in mind that all of these home power magazines, which are now out of publication, are still available online. Everybody who's on this call is going to get a link to this slide deck, which will have the hyperlinks to be able to go visit some of these websites. Go look. If anybody still has some old home power magazines, please put it in the chat there or the Q&A and let us know. But kind of
It's just incredible to look at the changes in price. You know, the solar panels now. You know, I bought a couple of pallets of panels recently, and I'm under 25 cents, you know, a watt shipped, you know, delivered to my door. It's incredible how the prices have changed, right?
And not only just on the panels, right, Nathan, but also the charge controllers, the inverters, and with the reduction in these prices, that we really are able to design very luxurious off-grid homes that have very little difference between a grid-tied home. And again, I want to just kind of emphasize this, that, a successful off-grid home design depends on the sum of all the parts, the loads, how you heat or cool the home, not just the solar and batteries. And we'll talk a little bit about this as we go through today. This was a great photo that I found. This is AEE Solar, Alternative Energy Engineering, and this is one of the very first distributors of renewable energy equipment before anybody really had thought to put these on homes. And what you're looking at there are some of the pioneers. And David Katz is on the far right. He was one of the founders of AEE. Charlie Wilson was one of the founders of PV Cables. And Nathan, just look up at the roof there. You can see how small those panels are. I think those are only 60-watt panels. And then on the far right hand picture of the right hand side of the picture, you can see, I believe that's a solar hot water system, and you can see the tank up there to get the
Uh-huh.
thermosiphon.
Daniel, when Bell Labs first came out with solar panels in the 1950s, they called them solar batteries, right? The idea was is that they would eliminate batteries and the need for batteries in the telecommunications industry. And of course, now we're seeing panels paired with batteries for off-grid systems. And I would argue that there are going to be people that are choosing to go off-grid with energy rates as I'm seeing now going up to 66 cents per kilowatt hour here in California.
Yep. Yeah,
Yeah.
absolutely. Another kind of history of Briggs and Stratton is, there's a lot of energy storage companies out there, and a lot of them have just recently started up. Briggs and Stratton is over a 115-year-old company. And one of the key things to the solar roller coaster that a lot of you may have been on is that we're going to be here to support you and your customers when the time comes. Everybody's offering 10 or 15-year warranties, just like we do. But is that company going to be around to support that warranty? So we've again had a lot of history, and one of the fun things, if anybody ever makes their way out to Milwaukee, Briggs and Stratton headquarters, would be happy to give you a tour of our museum. And in the museum is this washing machine, Nathan, that I've shared before on this call, but it just goes to show you how long we've been in the business, and how before the advent of less expensive solar panels and batteries, we leveraged a lot of gas power to wash our clothes, for example, here. And we actually surprisingly made these all the way up to 1984. And then Nathan, we also just created a solar power lab, right, where we put some modules up on our
Yes.
garage. Want to just talk a little bit about that?
Yeah, sure. I mean, Briggs and Stratton has long been known in energy as a manufacturer of generators, right? And about 3, 4 years ago now, they acquired SimpliPHI Power that was making lithium home batteries, right? And now we're really seeing a need, as you'll see throughout this training today, to combine generators, batteries, together with solar, right? The drop in solar prices have made it very easy to harvest energy from the sun at affordable prices. You can get a 10 kilowatt system for $2,500, right? Now, of course, you have to buy other components and assemble it, as you mentioned, Daniel. But we wanted to be able to demonstrate and test equipment as we pair our equipment with others in the industry. And so if you're in Wisconsin, if you come to the Briggs and Stratton headquarters, as Daniel said, it's wonderful to go through this museum. We have a hybrid car there from the 50-year-old hybrid car that Briggs put together. A lot of engines there, a lot of history, both with batteries and with engines. So we encourage you to come and see the facilities that we have.
One of the people I always like to highlight is a gentleman called Randy Udall. He was really one of the very first pioneers, just like we had shown earlier. And he had a great quote that I found in this Home Power article. For decades, cheap propane really was the dirty little secret of off-grid living. You use propane to cook your food, to heat your home, to heat your hot water. And that reality has really gone away. Nathan, I just filled up some of my propane tanks for my barbecue in the backyard, and it was $3 a gallon. And you realize how expensive propane has become. with the advent of very less expensive batteries, more powerful inverters, we can really wean ourselves off of this propane kind of dirty little secret in a lot of ways. And looking back at, go ahead, Nathan.
Well, I would agree with you, but it certainly is a convenient way to produce heat, right? And there are ways to reduce the amount of power you need to pull from batteries by doing things efficiently. But Daniel's going to point out in this talk there are heat pump based water heaters on the market now. There are high efficiency refrigeration systems that are there on the market now, and so there are a lot more things available now that didn't used to be, and much more affordable prices. I would even argue, Daniel, I've installed a number of on-demand water heaters this past year, and they use a lot less natural gas or propane, whichever you choose to use. And customers are quite happy with them, much more stable than they used to be.
Mm-hmm. Yeah.
Also, much more efficient, right? Not losing continuously from those tanks, and cheaper overall.
In the same magazine edition of this issue of Home Power, Nathan, I found that NABCEP has been around. I know that's been a great industry training, and they had an ad. And then also my old Sunfrost, where I worked at, was also had an ad in here as well. So it was kind of fun to go back and look through some of these old editions. Nathan, when I was doing a little bit more research for this talk, I came across this great article in Solar Builder magazine, and it came up with this term called grid defection. And there's a couple of quotes I just want to read out. Again, everybody's going to have access to this slide deck, but in a lot of ways, Sequoia Cross, our boss, right, was quoted, the off-grid market for solar plus storage has been a relatively small kind of blip on the overall radar of the market. But it's interesting to see that the off-grid storage market continues to grow faster than the grid-tied market. Although, the grid-tied market is much larger, the off-grid is growing, though it's maybe a little harder to track. And, right now we're seeing an increasing number of people that are looking to live off-grid. Also in this article on Solar Builder about grid defection, there was a study by Thompson Endowment that, PV hybrid battery systems with maybe 25% of or less of a generator can make grid defection economically possible in cases where electricity rates are so high and that there are reasonable solar resources, right? There's kind of a sunnier parts of the country. And the authors state that these results indicate that regulators must be careful to consider mass economic grid defection as a near-term possibility. Additionally, in this article, again, everybody could read this, is, Jeff Spies, he said, one limit to this kind of off-grid growth is a lot of DIYers out there, and they're buying the cheapest of components that they can find on the internet with little or no, out-of-the-box integration. And these people are kind of failing to grasp that the cheapest options out there is not going to give you the best value. It's probably going to be the worst value, and that one way to ensure your equipment choices are going to be the best is to integrate, a very good plan set designer. And I think that's where Jeff Spies is kind of plugging himself, because he's works with Planet Plan Set. Nathan, anything to add to that?
Well, I think this topic of grid defection, I mean, it's not new. It's been around for 10 years. I was reading a book that came out about a decade ago called The Grid. And they warned that we are approaching costs, right, where your payback period is 5 years, for grid defection. I look at my electric bills, and a couple $100s a month adds up to $2,500 a year, and it doesn't take a genius to do the math and figure out, well, how long would it take to pay off my system, right? Even with interest, you can pay your system off long before the components expire. And solar panels themselves, they will last 30 plus years. The batteries, we have batteries we warranty for 15 years, unlimited number of cycles, right? We have, we're seeing strong warranties. We're seeing systems that are going to continue to produce. And I do think that as prices continue to rise, you will see grid defection. And so this off-grid living talk is applicable to those that are on the grid that are trying to purchase less electricity at high prices. So it'll be interesting to see how things play out in California. Now, there are plenty of places around the country where electric rates are 5 times cheaper than they are here. So I'll let you keep going. It's an interesting topic for sure.
Yeah, Nathan, I wish this was my home. This is a picture of an off-grid cabin up here in Humboldt, California, Humboldt County, California. Not far from Redway, I believe, in this picture here. But if we think about this property and what it costs to get the grid, to get utility lines out to the property, and you start to see that these costs can really add up. So what you got to kind of do the financial feasibility study, thinking about what does it cost to get utility out there, and what might it cost just to have a complete off-grid system. These are going to depend upon how far that utility line is from that property, whether or not they need to add a new transformer to the line, whether or not they're going to do an overhead or an underground, and maybe if there's any sort of easements or zoning laws that might preclude you from being able to easily bring grid out to this property. So you can see here that, they got a little ground mount array and a beautiful cabin. I do notice a nice large wood stove chimney on that house there, Nathan. So you had mentioned it earlier that a lot of the energy that goes into our homes is usually for heating and cooling. So a lot of times we can see people using propane for heat or wood for heat as well, especially with all that big forest there. But now with the advent of heat pumps, which we'll talk about here in a minute, it is possible to not have to leverage wood or propane to heat the home as well. Talking a little bit about, do we want to bring in grid or do we want to bring in a battery with perhaps a generator associated with it and solar? So like you mentioned, Nathan, these PV modules are just incredible. Really, they show very little degradation. All panels degrade over time. And a sign of a good panel is that at the end of its warranty period, it still has a high percent of its power production. Nathan, right, the REC Alpha Pure solar modules we put on the power shed out there in Milwaukee, I think we're rated at 92% of their rated capacity after 20 years. And they'll probably continue operating for much longer than that. If you're not having to do a generator, right, there's no maintenance, no fuel, no sound. Back in the day when you had an off-grid home and you didn't have grid, you didn't have solar and batteries, you just run the generator during the day, did what you had to do, and then shut the generator off before you go to sleep at night. Generators, right, we don't have to have propane tanks coming in with the big propane tank. And with these battery and solar systems, we can scale the systems up. We can scale power and energy separately. And with, I'm trying to guess the altitude of that cabin I showed you, but, engines do derate with altitude, and you're not seeing that with these batteries as well. Though keep in mind that these battery plus solar systems do have an initial cost. And so you have to, like I said, do the financial analysis, whether you want to bring in grid or bring it onto a autonomous system with solar and batteries. Not everywhere gets the same amount of sun. Up here in Humboldt County, right, we get really long, rainy winters. So we're going to look a little bit about how to size those systems and account for that solar insolation as well. And a lot of times when we're not doing grid, there's not necessarily that unlimited source of power and energy. So sometimes it takes a little education on the homeowners to understand when the batteries might be running low, adjust your behavior. I'd also say when the batteries are full during the day and there's loads are being satisfied, go ahead and start to do things, because if you don't have grid to feed back that excess solar power and the batteries are full, that's not going anywhere. And it's better to use it up, do the laundry, bake a cake, or whatever it may be. Really quickly, we're going to talk through some of the just basic types of off-grid systems. And one of the most basic ones is these integrated systems. You can see down in the bottom corner, one of these like little radios, or maybe one of even these solar lanterns, right? All of the parts and pieces are built into it. That solar panel, the charge controller, the battery, It may or may not have an inverter. And up in the top right is one of our Jenny systems that is kind of more expeditionary. Another interesting thing Jeff Spies had published, and you can get a link to this on the Solar Builder magazine. This is a separate article in Solar Builder, is the idea that the market is kind of being flooded with these mobile energy storage systems. And you can see a picture of one right there. That the idea we're now creating very high capacity. I mean, there's a lot of energy that can get stored in these systems. They have built-in charge controllers, built-in inverters. But in a lot of ways, it's kind of an unregulated market. So take a look at this article. Jeff Spies is quoted with, will restrictive fire codes backfire and drive customers to unpermitted, unregulated, and potentially unsafe home battery systems? All of our energy storage systems in the market have to, achieve UL 9540 and go through a lot of fire testing. So it's interesting to see the influx of these. And Nathan, you and I were down at the last big, I think it was Intersolar, where you see a lot of these portable systems hitting the market. Nathan, anything to add to that topic?
Well, you just make a great point, Daniel, about, these are the kind of things you take camping. You throw it in the back of the truck, it bounces down the rough, fire road or wherever you're doing your camping trip, and then you bring it back and you put it in the house. Right. And so I think that the concern is real, that these systems are not going through the same kind of fire safety tests as systems like ours, right? And so they're probably not nearly as safe. And it's something to keep in mind, if you use one of these, is safety is an important factor in this. And if you are going to get one of these kind of portable lithium battery generators, who would encourage you to get one, at least a name branded one that has, some level of safety built into it.
Stepping it up a little bit, the day use systems, and we used to see this a lot, especially when the cost of batteries was very expensive. There's ways to just use solar, perhaps just to pump water uphill. And when you pump it uphill, you're building up the voltage, I would say, and the amount of water that you store in that tank is the energy capacity. So that was a really interesting way to do that. You usually have a couple of solar
Yeah,
panels.
this
And
is still
go
the
ahead,
way to
Nathan.
do it, right, Daniel? I mean, this is still the way to do it. So if you're in agriculture, it doesn't really make sense to use batteries to pump, at nighttime. And it's still the way if you have an elevated tank or an elevated location. The amount of water used in agriculture is immense, right? You talk about acre feet, right? And so you would need a large holding pond, but if you have an elevated location that you can pump to, you can absolutely, do energy storage through that water tank, as you were talking about. And it's also, many of these pumps are essentially direct drive. So what you're looking at, that pump controller there that says Sun Pumps on it, just got an email from them today. But Sun Pumps is, those are basically MPPTs, which maximize the power output of a solar array and direct drive a pump, like you can see there. That's a submersible that you're seeing. And Daniel's also showing in the bottom left, you're seeing, direct drive fans for ventilation purposes as well. Um, these are still quite popular in agriculture, especially around us. I know that we have a large number, especially just pumps to fill water tanks for cattle.
Yeah, and Nathan, I've heard them called linear current boosters. Is that essentially just an MPPT?
Essentially, that's it. Yep. Yep. So
No.
you buy a pump. So I've got 180 volt sun pumps pump out in my garage, actually. So you buy a pump at the voltage that gives you the kind of the power output and flow rate that you're looking for. And then you supply a solar array, and that pump controller is essentially designed to deliver current to that DC pump at the voltage that is specified at. So it's very similar to delivering current to a charge controller at the voltage that the battery needs.
Yeah, and you get unlimited cycles on something like this. Let's step it up a little bit. we're now going to add storage into the mix. And these are essentially, again, what the old cabins used to be back in the days. And maybe there's still an application in the future, the current status or in the future. No inverter. So what we're looking at here is we have one of those SunSaver MPPT charge controllers. We got solar feeding in, and then that controls the charge, right? The bulk, the float, the absorb, disable the equalize, and we can charge up our batteries right there. And then we don't have an inverter, and we got some of those 24-volt light bulbs. And the reason I chose this one, the 15L, is that it does have a low voltage battery disconnect. So what it will do is when the batteries start to get a low state of charge, it will turn off that load port right out of that. You can see that Blue Sea Systems little fuse box there and shut off of those loads. You can see I do have my refrigerator down in the bottom right. Again, a DC refrigerator that's not being connected through that SunSaver, and I got it feeding directly off the batteries. Two reasons. One is sometimes the amp draw on the startup of that compressor inside the refrigerator might exceed the 15 amps capable of that SunSaver. And knowing that a lot of the refrigerators also have a variable low voltage battery disconnect built into themselves, so I don't need to rely on that. There is an interesting article from NREL that I found where it talks about how DC architecture might make a comeback into the homes. The idea that we have these USB-C plugs that have become very common, and some of those can do up to 100 watts, and also the ability to power a lot over Ethernet cables. So imagine you don't have wall outlets for your lamp or your phone. They're just USB-C plugs. Very interesting article. Again, everyone's going to get a
I
copy.
think there's a couple of points made here. And Daniel, I mean, you're making the point that there's no inverter here, right? This is a solar charge controller directly feeding batteries, and then those loads are all DC loads. And a couple of points. So one, I mean, we're talking, this is an off-grid talk, but there are a lot of off-gridders or RVers. And many of the systems inside an RV are DC. So a lot of the lighting that you'll see inside an RV is DC only. Well, as soon as you add an inverter into the mix, there is a piracy draw of that inverter. So if you're not actually using much power, a sizable fraction of, percentage of your energy is going to just keeping that inverter alive. And so DC lighting systems, DC systems don't have that piracy draw. And so, there is definitely a market. I think there is a market for lighting systems. I just installed a bunch of lights in my shop that are LED lights, where essentially it's an AC to DC converter to drive these LED lights, and they're still more efficient than fluorescents, for instance. So I do think that there's going to be a market for especially lighting DC.
Yeah.
And DC loads where the inverter can shut itself off when AC is not needed. So something to keep in mind.
We're going to go one more step up. We are going to add an inverter now. And we're still keeping some of that DC architecture there, but we've added that one of the Morningstar SureSign inverters. Again, I think, yeah, Nathan, this would be a great example of what an RV would look like. And a Victron, I think, makes a lot of great equipment. So you could easily swap out a lot of this parts and pieces for Victron, which our batteries absolutely do work with right there. Notably, I did have to add a combiner because I want to combine my battery bank and then be able to feed the DC up to the SureSign, right, the inverter, and then also be able to bring the DC down off of my charge controller as well. I think we're getting close. This is probably what we're looking at now for a modern off-grid home, right? We're not really going to run the DC loads. What we're doing is using a hybrid inverter like that Solar 12K you see on the screen to bring everything over to AC, combine a generator, that solar using 2-wire signal to start, can start up that generator when the state of charge of the battery gets low. The generator will take over the loads and then also be able to charge the batteries. And Nathan, I know you do a great talk where we talk a lot more through the architecture design of this and also how to program this stuff as well. So stay tuned for upcoming webinars where we dive a little bit deeper into this. Again, and I mentioned this earlier, a lot of the size, the cost, and the functionality of an off-grid system really depends upon the loads. And if the home is being able to use propane or wood to heat, maybe even to cook there, and you can see that stove there as well, those really efficient DC loads that, I mean, a light bulb, right? In a lot of ways, Nathan, is no more efficient whether it's AC or DC. It's the conversion losses that we see. You do the tasks during the daylight. You might want to live without some unnecessary items. I don't know if a dishwasher would be unnecessary for me, Nathan, but a clothesline, for example. And then also make sure you educate the homeowners on the seasonal variations and the loads, right? In the winter, we get the least amount of sun, but we're also going to probably have the most demand for heating the home as well. So you kind of see the Bico washer and some of that stove, but I would argue in a lot of ways that with the advent of low cost, reliable, long lasting batteries like Briggs and Stratton is manufacturing, and the lower cost and more powerful inverters like a Solar 15K, living off grid really doesn't have to feel like living off grid anymore. But it will if you're using your composting toilet. Please put in the comments or the Q&A if anybody's using Sunfrost made a composting toilet for a long time as well.
Haas has a couple of comments, and I'm sorry I've missed these. It came in about 7 minutes ago. He says TerraVolt builds portable systems from 1,000 watts to 15 kilowatts using the PHI batteries. The larger systems are designed to interface with portable or installed solar and can be grid tied with NEC approved connection. So yeah, so Haas is sharing that there for us. Um, Off-grid space water off-grid space or water heating. So space heating, I've seen a lot of kind of DIY. I haven't seen a lot of um, solar panel space heaters, but I've seen DIY ones. And Daniel's showing one that we saw at the show. That's a flat plate collector style water heating panel there. What are we looking at for the second one in, Daniel?
This guy right here.
No, sorry, the second one on your display here. So you're suggesting that we've really moved from what's on the left to the heat
Yeah.
pump water heater,
Yeah,
right?
heat pump water heater. You know what's interesting, Nathan? This one I do want to call out. What I believe this is, Sun Bandit. I don't know if you've heard of that company, but essentially what we do is we take solar panels and we feed them directly into an electric water heater, no batteries. And
Hmm.
so it's a lot of ways we get rid of all the plumbing, the drain back, the pressure relief valves that are associated with something here, and just feed the solar directly into a tank. Once the solar, the water is hot enough, right? The panels, the charge controller is shut off. So I like more of a hybrid approach where we can still maybe direct that into a battery. But yeah, kind of what you're looking at here is a heat pump water heater. So a COP, right, Nathan, is for every 1 unit of electricity you put into a water heater, you might get 1 unit of heat out of it, or a little bit less. But with these heat pumps,
Yeah,
yeah.
I mean, really with these systems, about the worst you can do is one. And you could get 4 or 5 to 1. It really depends on the ambient conditions. So one of the nice things about it is if you are in a moist environment, heat pumps are a lot more efficient. One of the reasons they're more efficient is they can pull heat out of the air by condensing water vapor. And if you're like Daniel and I have a ton of tools in your garage, then the benefit is it keeps your air drier in the garage. Of course, it keeps it, it's pulling heat out of there, so it cools the garage a little bit. But it can significantly boost the performance of a water heater, giving you 3, 4 times the performance, with the same amount of electricity use. Or essentially, if you're using the same amount of hot water, probably 4 times a reduction, 3 or 4 times a reduction in your electricity consumed to heat it.
Yeah,
So
because you're moving heat, right? You're not just have a resistive heater.
absolutely.
This is actually a wood boiler here, so this is not only gonna heat up water for domestic use, but also for space heating as well. Again, what I've seen, and I'm sure a lot of other people have seen, is the advent of heat pumps, and a lot of these heat pumps have DC inverter compressors so that they don't have as large of a surge that you would see on some of the older air conditioners or heat pumps. Not everybody likes the mini splits, which is kind of the things that hang on your wall. And that's fine because there's a lot of multi-position air handlers. So it's the same air ducts. And Nathan, I've even seen these be able to work as a boiler where you can do radiant as well. So interesting to see how we're using electricity to move heat rather than just burning up in a resistive heater or moving away from that wood and propane. So one thing to keep in mind, what we're going to do here after this slide is size the system really quick, but I just wanted to take a step back is that, what affects the production of a solar panel array from making power, right? The temperature of the panel, right? So the hotter it gets, the voltage drops on those panels, and the colder it gets, the voltage goes up. The latitude is going to affect how much atmosphere the sun has to pass through. Also, the latitude and also local conditions will also affect the amount of solar insolation or the amount of sun you get over the year as well. And then also, is the solar panel tilted in the right direction? And I got a great slide coming up that we're going to talk a little bit through that. And we talked about this earlier, but the availability of the power equipment to take the energy in. This is kind of the idea that if by noon, solar panels are still producing power, the batteries are charged, the loads are satisfied, the power's not going anywhere. And you could argue that or say that the same thing now applies with the new net metering agreements, where you're not really getting anything for power exported to the grid, and you need to really be able to use that or store it in batteries as well.
Well, and this is an argument for sizing your system appropriately, Daniel. I think, I see I'm in a number of these forums, the DIY kind of forums where, people help troubleshoot each other's systems. And, it's probably every week somebody asks a question about why their 10 kilowatt array is not producing 10 kilowatts, right? Their batteries fill up and their array is not feeding in the excess back to the grid in an off-grid system. And of course, the array is not going to produce 10 kilowatts if there's nowhere for the energy to go. So a good point that you got there on the screen.
So to size an off-grid system, what we got to first figure out is how much energy they use, and then also figure out how much power they might use. So energy, right, is measured in watt hours or kilowatt hours, and then the amount of power at any instant moment would be measured in watts or kilowatts. So we're going to do that, figure out what the loads are. We're going to figure out how many batteries they need and how large of a battery bank. Figure out the size of the photovoltaic array. We're going to size that charge controller. Make sure that inverter is capable of providing the amount of power we expect. And we're going to talk a little bit about the wire and other parts and pieces you might need. On the screen here is one of our access cabinets. This is an older Solar 12K, Nathan. I kind of left this here is because it just goes to show you how long SimpliPHI Briggs Stratton has been making batteries. And we were really one of the first people to be partnered up with Solar. Now, the Solar 12K looks a little different now, but we still offer this as an option for somebody that can't necessarily put batteries in a garage or on the side of a house. And we can put this separate away from the home. We can also add heaters inside this system. So if you're in a really cold weather location, we can make sure that these batteries are heated during cold weather. So we're taking a look at my proposed off-grid home. In a lot of ways, we need to do two things. We need to look at how much energy a system, an appliance might use, and then figure out how much power. Now, realize that not everything is on 24 hours a day. So if you look at, for example, that TV, right? We're only watching 4 hours of TV a day. That may be a little or a lot for some people on this call. But also keep in mind the lights, right? A refrigerator isn't always going to use 100 watts, right? It's going to use 100 watts for maybe 15 minutes and then shut off for 45 and cycle on and off. So what we look at is the run watts, the quantity, and then the run out time hours per day. And that's going to give us the amount of kilowatt hours per day we expect. In our example, we're going to be right around 4.6 kilowatt hours, which is kind of low. Nathan, I know you have a lot of gas appliances in your home. How many kilowatt hours a day does your grid-tied home use?
Well, that's a good question, Daniel. It's drastically changed in the last couple of months.
Yeah,
I
that's right.
finally put an electric vehicle charger in, and now it's gone way up. I also fixed our hot tub, so my daughter's happy about that. The electricity company is probably going to be happy too. Um, hey, before we move too far on,
Yeah.
a nice easy way to estimate that is look at the number of kilowatt hours you use over a month and then divide by 30 days. So for me, I'm kind of well below. I have been well below the average probably until this last month. I'd use about 600 kilowatt hours in a month. Divide by 30 days, and I've got 20 kilowatt hours in a day. Now, for an off-grid home, that might be a lot. For a grid-tied home, it's not.
Yeah, that's great. Somebody who's looking to do grid defection, right? You already have
Mhm.
history of what their kilowatt hour consumption was per month. You could probably pull interval data and see what their power demand was. And,
Yes.
and yeah, for an off-grid home, that's just being built or maybe is existing, right? You should be able to at least figure some of this stuff out as well. What we're
Hey,
doing, we
Daniel,
got our,
before I
go
let
ahead.
you move on here, we've got a question from Jeremy Zinn. He was asking about the access cabinets. He says, what would happen if the heater failed in the cabinet? Would the battery be damaged? I'll take this one if you don't mind,
Go ahead.
Daniel. Jeremy, the heaters are directly integrated into the battery management systems, and they attach the heaters Daniel was speaking about are more efficient than just heating the cabinet. They directly heat each individual battery. So there's a there they are a special order battery for us. We build them in Oxnard with that integration I was talking about. So there's temperature sensors inside the batteries, and the battery temperature is what controls the turning on and turning off of the heaters. I don't believe we've ever had any of these fail. To my knowledge, in tech support, we haven't had any of these units fail. But no, the batteries should not be damaged. And we don't overheat these cabinets. So good
And
question.
Nathan, if say we didn't have a heater on a battery and the battery started to get cold, would the battery tell the inverter to slow or stop its charge rate?
Yeah, so if you, as the batteries Daniel was showing there, are amplified batteries, and so those batteries have a very sophisticated battery management system in them that will slow the charge rate of communicating inverters like SMA inverters or the Solarc inverter that you saw in that access cabinet, and so it should slow down charging and discharging rate as well. So yeah,
Great.
good points, good question, Jeremy. Thank you for asking.
We'll keep it going for the sake of time. So on that last slide, we talked about how much kilowatt hours a home consumes per day. We take that and then we have to account for some inefficiencies, right? The inverter inefficiencies. So we're going to bump it up by about 10%. So we're expecting we need about 5.1 kilowatt hours per day. Then we take that and also realize we need to get some days of autonomy. So we need to make sure that we can go 2 or 3 days. A lot of times after that amount of time, the clouds are going to go away, the sun will come up. And so we need to multiply that 5.1 by 3 days of autonomy. That brings us up to right around 15 kilowatt hours. And then also realize, yes, our batteries are able to do 100% depth of discharge. We don't have any limitations on our warranty with that. But again, kind of best design practice, we're going to say, look, you can use 80% of the battery's capacity, but leave 20% in. So 80% depth of discharge. That brings us up right around 19 kilowatt hours. And what's cool is that we can use some of our phi batteries that you see up here, or the amplified batteries, but also our new 6.6 stacking battery. Well, it's not that new anymore, Nathan. We've had it out for a while now. Great success with it. We
I've
we can
got
do
several
one
thousand
stack
of
of
those in
three.
the field now.
Yeah.
And of course, days of autonomy is going to depend on the customer, right? And whether or not they've got a generator on site.
Yep.
So
Yep.
um yeah, anyway, good points here.
So we figured out how much battery we need. And that's absolutely right, Nathan. We could do 1 day of autonomy if we have a generator to charge it up. But we're going to take a look at a map here. What we want to figure out is how much sun does our off-grid property get? And that's going to help us figure out how much solar panels we need. So this map here out of NREL is a great map for used for grid tied system that has a net metering with an annual true up, right? Tells us the average direct normal solar irradiance over the course of the entire year. This would be good for a grid tie, but what we need to understand is I really want to size my system for one of the worst months of the year, or winter. And what we have here is a picture of a map out of one of those AEE solar catalogs that used to be published. And you remember I showed you earlier that Dave Katz, right? That was in 1982. This is like 20 years later, or 25 years later, is AEE is what it's come to be. And now this is almost 15 years old now at this point. But in the back of the map was this, and we're going to size our system for Milwaukee, Wisconsin, where we have just done that. And I can see on our map during the worst months of the year, I only get about 2 hours of solar insolation. That doesn't mean that the sun is only up for 2 hours a day. That means that in the winter, the sun probably only kind of comes up just barely over the horizon. It's up for a little bit and then sets. That's accounting for weather. And
A
also
lot of this has to do with the weather, right? So,
yeah.
if you look at a parallel latitude in the drier parts of the country, you can see 4 hours, right? So a lot of it has to do with the moisture that sticks around in the winter months, and as Daniel said, the shorter days in the winter have a big effect on the amount of solar production you get. Daniel, you mentioned the weather and where you are is wetter in the winter, and that's when our wet season is out here in California. Now I'm about 6-7 hours south of Daniel. I'm in San Luis Obispo, California, but I typically will see an extra 50% production, even more than that in the summer. So if I take my summertime production as a standard, I'm only getting about 60% of that on a winter month that I get on a summer month. And a lot of that has to do with the length of the days, but also the weather.
Yeah, that's a great point, right, Nathan? You'd think that the latitude would be consistent, the insolation, but you can almost see, right, the rain shadow created by the Rocky Mountains is in this desert here is really why we're seeing a lot more
Yes.
production. There's a couple, so we figured out how much sun we get. Now we got to figure out how much, is there any shading impacting the solar array? And one way they used to do it is we use one of these solar pathfinders. But a new interesting way, and there's a lot of tools out here, is Open Solar is a company that's a solar proposal tool. So Nathan, this is actually my house here that I did. And rather than just getting up on the roof with the old solar pathfinder, which is still a lot of fun to do, and you can do that.
Daniel, I've listened to you mention the solar pathfinders for a few years now, and mine is finally arriving today. I bought one off
No
eBay.
way.
I like older tools like that, and just I kind of like the history of all of it. So I just got a notification earlier today that the one I had ordered is coming. But you make a great point here, is we don't need those kind of tools anymore because we can do it with software.
Remotely. And
And
and what I'm
yeah.
showing here is my house here, and what I show is the some solar panels, and you can see in my backyard are all these big trees. And what I did is I was able to select a solar array, and then I'm able to select just certain hours and certain days of the year, and what it can show me is what my shading expectation is. So there's the annual sun access, right? 82%. And then this TSRF, total solar resource fraction, really what that's accounting for is the annual sun axis is just accounting for shading. But when I do the total solar resource fraction, what that is accounting for is both shading, but also the tilt of the panel and the orientation of the panel. And what's great, Nathan, about this open solar is that I can these trees actually, fortunately, have all been cut down. So I can come in here and open solar. The imagery just hasn't been updated yet. I can come in here and virtually cut down these solar panels, cut down these trees, and then be able to get an estimate of what shading is going to impact us.
So you have customizable, you have control over the shading that is there. Before we move on, Haas asks a good point on draining batteries to zero you now might have a dark start issue, and most inverters won't start without the 24 or 48 volts. Does the Solar Arc have a black start capability? For everyone, what he means there. So the answer is it depends on how you power your rapid shutdown devices. So if this is a roof mount array where you have rapid shutdowns to be in compliance with fire code, and you're powering them from a DC source, then yes, the Solar will have dark start capability. It should, when the solar comes up, it should see it and then start up and start charging the batteries. Now, if you've hit the low battery cutout by going to zero, the Solar would take some time before it restarts loads. But the point I believe you're making, Haas, is that some of these rapid shutdown devices, if they're powered out of a load center, will not let the inverter see the panels. That's kind of one of the downsides to the rapid shutdowns, right? Is that they have to have a keep alive signal. So I would encourage those that are going to frequently hit, drain their batteries to zero, to look into having a DC source of electricity direct from the batteries to keep those rapid shutdowns alive. So you can absolutely do that. And in fact, the AP Smart rapid shutdowns, you can power directly out of the control board on the Solar unit itself.
Yeah, that's a great point. And that just kind of shows you that these inverters do have a parasitic draw, even when they're not supplying loads, and they
Yes.
can continue to drain the battery. 4.6 kilowatt hours a day. Remember, that was our load. Now what we're going to do is figure out our solar panel. So we're going to account for some little inefficiencies in the battery. And Nathan, I don't think we have time to get into it, but that efficiency of the battery, I think, depends a lot on the rate at which we're charging or discharging the battery.
Absolutely. Yeah, it
We're going
depends
to
on the
talk.
rate and the temperature.
Yep, thank you. We're gonna knock off about 40% for that shading. Remember, it showed about 80% on that open solar proposal, but I'm also going to knock off a little bit just for some other system inefficiencies, I should say. I remember we're up in Milwaukee in the winter, so we get about 2 peak hour sun hours a day. So what that means is we really need a 4-hour kilowatt array, right? So if we go out and put a 4 kilowatt array in the sun for 2 hours, we're going to get 8 kilowatt hours. But accounting for all these inefficiencies, really, we're going to be closer to about 4.6 kilowatts. Now we need to specify the charge controller. 4 kilowatts used to be a lot of solar, and you can see some of these old Outback charge controllers here could handle that. But in these new Solarcs, they can handle a lot of solar power. I mean, even the Solar 12K can do 13,000 watts of solar. Moving a little fast, just so I want to make sure we leave time near the end, Nathan, for questions. Now we got to figure out the inverter. Remember, we want to make sure we have an inverter. This is kind of how we used to do it on the left is the inverter, the charge controller, the Mate 3S, the automatic generator start. What's cool about, and it's still possible, I know Victron, right, Nathan, still does a lot of it this way, and there's advantages and disadvantages, but we've seen a lot of hybrid inverters come to the market where they put all the parts and pieces together on this. So we know we have a Solar. We only need to really be able to power 1,700 watts continuously, and we're only going to surge to 2,400. Again, we could scale this up if we have a more fancy off-grid home. We do know that Solar 12K is easily able to handle that. We can, get 9,000 watts continuous out of that Solar directly from batteries. The Solar 15K can do 12,000 watts, and it can even do more if it does have solar contributing as well. One thing I want to keep in mind is when we're running conductors for off-grid systems, a lot of times, and especially if we're doing DC systems, that we're upsizing some of those cables. So, when we have, for example, say we had a Sunfrost, right? And the Sunfrost is using 10 amps at 24 volts. That's not a lot of pressure in those lines, and it's 35 feet away. Well, I go to my NEC code table, 10 amps, that's fine. We can run 14 gauge wire. We're fine. We meet the ampacity of that. But when we think about the voltage drop and there's only 24 amps of pressure pushing, we actually need to upsize that to 8 gauge so that we're not getting more than usually 2 to 5% of voltage drop is what's acceptable.
Yeah, I'd like to, remind people that this is really an efficiency decision, and when you have long wire runs from your array to your inverter or your charge controller, you want to do it at higher voltages and lower currents and, within the capacities of your equipment. Um, Keep in mind that, what's happening inside that wire to generate that voltage drop is the creation of heat. And that's an inefficiency in the system. And I've seen other questions, people asking, hey, why am I only getting, 7,000 watts when my optimizers tell me that my array is actually producing 7,800? Why the discrepancy? Well, the discrepancy has to do with that power lost in um, your long runs, right? So something to think about with ground mount arrays, which are typical in off-grid systems, is Daniel's absolutely right. You want to use it's a one-time cost. Use a larger gauge wire.
Yeah, yeah, maybe use the 10 gauge PV wire and not your 12 gauge PV wire, for example. Another thing, and a lot of people want to make careful on this, is when we're talking about ampacity of conductors, not only is it the wire temperature rating, but also the terminals that are either in the breaker or in the inverter, right? They all have a rating for a certain temperature, and that's going to influence or make you decide which part of the NEC ampacity charts you want to take a look at it. Well, here's our system, right? We used 4.6 kilowatt hours a day. We have a stack of just under 20 kilowatt hours of battery, a 4.2 kilowatt array, and we know our inverter and charge controller will be able to handle that. And Nathan, I am going to go ahead and put one of our 13K generators on there as well. Not very different than the system we did out in Milwaukee. This would be a more fancy version, right? Now we've stepped it up to a 15K. We got 40 kilowatt hours of battery. There's those rapid shutdown modules that we have to be a little careful about, not doing a black start on. We've upped it to a 22K generator, and we're backing up the entire home. Lots of other calculators available, not only for the load that we talked about on that first part, but also the solar production. And then again, the open solar link. For sake of time, Nathan, I'm going to keep going a little bit faster, but again, make sure you support that IRC, reach out to everybody, your lawmakers, so they understand how important that 30% tax credit is to our industry. This is a great picture, Nathan, of what it can look like to replace lead acid batteries with some of our Phi or amplify, or even the 6.6 batteries.
So
Those are some of
Daniel,
our,
could you go back just a couple of
yeah.
slides? Keep going. So somebody asked anonymously, what's a ballpark cost of a system like this? This large whole home system is certainly going to depend on the installation costs. Equipment costs here are going to be somewhere around 20 to 25,000. And so it's a fair question. Can you go back one slide previously, Daniel? And a system like this, you're looking at equipment costs in the $15,000 to $20,000 range. And then again, it does depend on the installation costs. And Daniel and I are not super familiar with the cost. Certainly, our sales team is, and those batteries that you've been seeing, those stackable batteries, not only do they look great and are super easy to install, but they're also very competitively priced and have a really strong warranties on them.
And that's a good point, Nathan, is that, yeah, absolutely the upfront price matters, what people can afford. But when you start to look at, if we got lead acid batteries and they can only be discharged at 50% depth of discharge, you got to water
Cheap up
them.
front, the specs look, yeah, they're cheap up front and the specs look, good. But then as Daniel's pointing out here, we talk about levelized cost of energy. So Daniel, take us through what
Yeah,
does that mean?
in a case, it's really not looking at the upfront price, but looking at the cost of the system over its life, right? How many kilowatt hours can I put into a battery and get out of the battery over its life based on its capacity, its cycle life, its warranty, and its efficiency. So absolutely lead acid batteries or even some of those cheaper lithium ion batteries that are on the market might be less upfront on price, but to be able to recoup those costs and know that this system is going to be lasting for a long time, and also dealing with a company like Briggs and Stratton that's going to be there to support that when something may or may not go wrong. Yes, upfront price is important, but also so is the lifetime cost of it.
That's a
So
good point. Daniel, Karen has to go to another webinar at 11. She says, will we send out the slides and follow-up info? Um,
yeah, yep,
Absolutely.
absolutely. We will send a recording and the slide deck to everybody. Click on those. Make sure you read those solar builder magazines. Make sure you click on those links to take a look and get involved in the IRC as well. I want to just end it on this. Absolutely, our generators are approved for non-emergency use, which means that if you are combining our generators, which a lot of off-grid systems should be incorporating, especially if you want to reduce the number of days of autonomy, we can warranty our generators as long as they're paired up with another energy storage or an energy storage system or another form of power. Just to quickly end, right, we're really excited about our 6.6. It's not new anymore, but it is very easy to install. Apps are very important. Our Energy Track app is able to look at a lot of details. Our brand is well known, and we have a long history. We're not going anywhere. We're able to leverage a lot of our capabilities around the world, including our US-based manufacturing, and we are an agnostic battery, which means that we work with many other inverters. Thank you everyone for joining. If you're here for your NABCEP credits, please email energystoragetraining@basco.com, BASCO, briggsandstrattoncompany.com, and we'll be able to issue you those NABCEP credits for the continuing education. Nathan and my email are up there on the screen. Please let us know. Please reach out to us. And if you want any support designing or figuring out how to make a system work, our application engineers are available. Nathan, any final thoughts from you on off-grid living and maybe grid defection?
I think it's one of the more fun things to design systems for. And Daniel asked me this question about grid defection because I'm frustrated with how much I have to pay PG&E for electricity that I can make cheaper. So I think as I design my system using open solar, Daniel, I will have more thoughts on that in a couple of months as I try to take my in-town house off grid. But thank you everyone for attending. If you have questions, if you need to talk to an engineer about, wanting to design a system, our contact information is there on the screen. So Daniel, thank you for the presentation. Thanks to everybody for attending.
Thank you, Nathan. Thank you, everyone else.